Hi, I'm Miss Hearn. Let's get started. In this video, we're going to solve a system of linear equations in 3 variables. The method that we're going to use is step 1. We're going to select a pair of the given equations and use the addition method to eliminate one of the 3 variables. Step 2, we're going to select a different pair of the equations and use the addition method to eliminate that same variable from those. This is going to give us 2 new equations with 2 variables. Step 3 will solve the resulting system of 2 equations for the remaining 2 variables, and you can use either substitution or the addition method for this, but I'm going to use the addition method. And step 4, we're going to substitute the values for the 2 variables that we found into any one of the 3 original equations to find the value of the 3rd variable. So here we go. The system of equations that we're going to solve is given here. 5x plus 4y minus 5z equals negative 26, 3x minus 5y plus 3z equals negative 17, and 6x minus 4y plus 6z equals negative 28. For the purpose of being able to talk to you about them, I've numbered these equations, equation 1, 2, and 3. So those are just random labels that I'm using so we can talk about it. Let's look at step 1. For step 1, we need to select a pair of the given equations and use the addition method to eliminate one of the 3 variables. Now, I picked equation number 1 and equation number 3 because I noticed that the y's have opposite coefficients, so it's going to be easy to eliminate y using this pair of equations. I don't even have to multiply each equation by anything. I can just add the 2 equations together, and when I do that, the y's disappear. So I'm going to get 11x, negative 4y, and positive 4y cancel out, and then I'm going to have negative 5z plus 6z is positive 1z, or just z, and then negative 26 plus negative 28 is going to be negative 54. All right, so I've eliminated y. You can see this new equation here, 11x plus z equals negative 54, has only 2 variables in it. Now step 2 is to eliminate that same variable using a different pair of equations that we were given. So I used 1 and 3 to find 11x plus z equals negative 54. I'm going to choose 1 and 2 to get a new equation, but I have to eliminate y again. So this time it's not going to be quite as easy, but we can still do it. Right now, the y variables in each equation have different coefficients. In equation 1, the coefficient's 4. In equation 2, the coefficient's negative 5. We need them to be opposites. So you look for the least common multiple of 5 and 4, which is 20. That's the smallest number. They both go into evenly. And you think about what you would have to do to each equation to get 20 as a coefficient in front of the y and negative 20 in one of the equations so that they're opposites. So in equation 1, notice there already one is a positive sign and one has a negative sign. So we're good with the signs, but we need to multiply the 4 by 5 to get 20. So I'm going to multiply equation 1 through by the value 5. And that's going to, and you must multiply on both sides to keep the balance. So on the left, distributing that 5, we'll have 25x plus 20y minus 25z. And then on the right, multiplying negative 26 by 5 is going to give us negative 130. And then we're going to take equation 2 and multiply it through by positive 4. And again, remember, it has to multiply on both sides. So on the left, we'll have 12x minus 20y plus 12z, and then on the right we'll have 4 times negative 17 would be negative 68. So now we have opposite coefficients in front of the y. So So I'm going to add this together, get those to cancel, and we're going to have 37x, and then negative 25z plus positive 12z would be negative 13z. And then we have negative 130 minus 68 is going to be negative 198. All right, so yet another equation in two variables, the two variables x and z. So we found one by using equations 1 and 3 and another one using equations 1 and 2. And so these we're going to solve like a system of equations in two variables. That's going to be step 3. I've copied the two equations down here, and now I'm going to give them the names, the labels A and B. These are just random labels again, just so we can talk about it. So we're going to take these two equations that we just found with two variables, and we're going to solve this system of two variables for both x and z using the method of your choice, either substitution or the addition method. I like the addition method. So once again, I'm going to eliminate one of these variables. It looks like it's going to be easier to eliminate the z because in one of the equations there's no coefficient in front of the z. So it's easy to get opposite coefficients here. I can just multiply equation A by 13. And that's going to give me, let's see, 13 times 11 is going to be 143x, plus we have 13z equals, now negative 54 times 11 is going to be negative 702. And then I'm just going to keep equation B the same because I already have opposite coefficients here. So 37x minus 13z equals negative 198. Then we're going to add these two together. The z's will cancel out. That's going to give us 180x equals negative 900. So now to find x, all I need to do is to divide both sides by 180. And that is going to give us negative 5. X is negative 5. Now we know one of the values of one of the variables, and we can plug this value into either A or B to find z. To me, it looks easier to plug it into A. It has smaller numbers. So I'm going to take the value x equals negative 5, and I'm going to plug it into equation A, and that's going to give me 11 times negative 5 plus z equals negative 54. So negative 55 plus z is equal to negative 54. To get z by itself, we add 55 to both sides, and we have z is equal to 1. So now we have two values, x equals negative 5 and z equals 1. But remember, there used to be a third variable in the original set of equations. So all you need to do is step 4, substitute the values for the two variables that you found into any one of the three original equations. And then we'll use that to find the third variable. So we're going to take x equals negative 5 and z equals 1, and we're going to plug it into our original equation 2, which was 3x minus 5y plus 3z equals negative 17. So that's going to give us 3 times negative 5 minus 5y plus 3 times 1 equals negative 17. Or negative 15 minus 5y plus 3 equals negative 17. So combining like terms on the left, negative 15 and 3 combine to give us negative 12 minus 5y equals negative 17. We're going to add 12 to both sides, which gives us negative 5y equals negative 5. And then I'm going to divide both sides by that negative 5 to get y is equal to 1. So we have the value of the third variable. You can either, it depends on how, maybe you are entering this in My Math Lab or another homework system, depends on how they want the answer given. But you can write out x equals -5, z equals 1, and y equals 1. Or if you want to write it as an ordered triple, then they have to be in alphabetical order, x, y, z. So you're going to have -5 for x, the x coordinate, 1 for the y coordinate, and 1 for the z coordinate. I hope you found this video helpful. If you did, please remember to like it, give it a thumbs up, and that helps other students to find the video.